I'm Chris. I'm from hsbCad. I'm here together with my colleague Gilles.
Hi.
It's my second Accelerator. The first one was on Forge and Todd's large model viewer. But today I'm gonna tell you a little bit about why we want to do what we're here for. The hsbCad is all about wood construction and prefabrication and production of that wood construction. We have software on posts and beams, so for the more complicated tooling on beams, both plug-in in Revit as in ACA. But the bigger chunk of the market of our customers is about stick framing, a closed panel. And there's a new technology as well, or a new industry, which is CLT. CLT is it's part of the tall, or the driver of the tall wood building movement. It's basically from low quality wood, they create high quality engineered panels by cross. So CLT is an acronym for cross laminated timber. So it's different layers of wood glued together. That industry is divided basically in two parts. There's the companies that build the houses. Obviously they work around the project. They will possibly, but they will decide on all the detailed connections, how it needs to be mounted. They will also be responsible for what sequence they want to have the panels delivered on site. But yeah, and they will work in a BIM environment, possibly Revit. So you hopefully using HSB software to drive their design. But the other segment in the market is about the production of these CLT panels. You need quite some infrastructure to get these panels produced. You need big presses. You need lots of chemicals, polyurethane, glues, and everything. Then you end up with large CLT panels. Of course, they need to be cut, machined. So your machine set is expensive, is large. So there's companies that really focus on the production of these large panels cutting. And then the other side is the builders that need it. And it's precisely these two companies and these two sets of applications that are used that we are focusing on. Because these producers, they will be using tools to, let's say, to nest, what we call nesting, to put all these different individual panels into large panels that it can produce on the machine. They will also be responsible for the trucks leaving the factory and arriving on site. So they need truck stacking applications and so on. So that is typically not done in a BIM or in a Revit environment. These are different models that play around. For instance, they could use hsbCad on ATA for that. A lot of that, these different companies at different locations, possibly on the world, need to communicate, need to share these models. These models, they will have a relative, there's lots of change requests, obviously, in that production process and erection process. So there's a lot of communication going on. So there might be, or there are other applications involved to drive that communication. For instance, hsbShare as an application to drive collaboration, to drive, to track issues and everything. So it's these three applications. So our hsbCad on Revit, our hsbCad on ACA, and our hsbShare, our cloud application, that we need to hook up together to synchronize and to align with one source of truth, being potentially the HFDM repository. So this is the story or the problem. So what we want to communicate is all geometry, because the other application needs to do the nesting. The other application needs to do the machining. So the full detail of all operations. It's not just about there's a wall from there to there. No, it's the full details of all connection and so on that needs to go. We use our own data object model for that. Right now, it is also happening already, that communication, typically done over files. So either just sub files for solid representation, or it's hsbcad data, so that would be hsbcad model, CAD model files, or maybe IC files. These producers, they use any software. They use CADWorks, D3, hsbcad, whatever. I mean, they import all of these models. So there's quite some challenges on the communication basically. So HFDM here really has the potential of creating a platform for such communication. So expectations are high. So let's come to a demo. Maybe you can kick it off, Gilles.
Yeah, no problem. So let's start in the Revit environment then. There we go. So we all know this environment. This is a small model which has a couple of CLT panels inside of it with our hsbcad software implemented inside of it of them. So what we did is actually we created a ribbon that allows us to create and use all the functions that are available in the C# API at the moment. So let's start with creating a new repository. So as you can see, we created a new repository. I need to share this over all the applications, so I'm just going to push this in the Slack environment and give it to Chris. In the future, of course, this could be done by configuration, but that's how it is at the moment. Right now, I'm going to try and push all the data that's inside this model to the repository. Let's see if this works. We've had some issues with the stability of the program, but it's saying that it's successfully committed all the changes on the bottom. Let me check inside the HFDM inspector what's the result of this one. Yeah, so it's not refreshed already, but it's the same data. This is actually our own HSB entity that we are putting inside the HFDM inspector. What's inside this HSB entity is only the unique GUID that we receive from Revit itself. There's an action also, an action parameter also in this entity. We have a timestamp, a unique ID, and a user which is not filled in at the moment. Also, we have a map property, and that map contains our hsbcad geometry data that is now being transmitted to the ACA side. Okay, so now we can jump over the ACA side and we can import it there. I'll stop the share.
So on our ACA application, we'll go to Slack again. Get down to them. So we'll connect. So in ACA, we've done more or less the same. I did not have time to create a ribbon, but I've just created a couple of commands here. So set the URL. Then I have a method which is called hsbHFDM update. So obviously update will pull, it's an update in the meaning of a repository. So we update our current model from the state from the repository. So updated a small report at the bottom in the console, the amount of entities that were created, the models that Gilles was showing, just that changed this year into green. So we pull in not the complete, well, this is the initial pull. It does not contain color or material or anything that's not relevant in this workflow. So I can change it here, no problem. And it will stay. even after there's now changes to be done by Revit. So let's switch back.
So in this workflow that we are trying to show is actually someone, the manufacturer is saying to the one who drew this model, I have an issue with this wall. It's a little bit short. It's impossible to build this. So he's going to modify it. For example, or is it more in the way? For example, he needs to put another window inside of it in this wall. We change the length properties and the width property also. So we've done a couple of changes, and let's say we just want to commit them again to our repository. So I have a function there that's allowing us to commit these changes, and then when I go to the HFDM inspector, okay, now I've run this test before, so I know what the GUID is. I know this is the entity. We are seeing that action now is, instead of added, what we have in the other one is modified, and the map is also modified. So let's see what happens if we try to update in ECA then.
So when we're going to update again, there's a couple of things popping up. You can touch that later. Yeah, that's part of the current sample implementation. Basically, it's just
authorizing and getting a bearer token.
So you see, I just pressed the geometry of the graphics updated, and it pulled in the changes. It's not that new entities or something are created; they're actually updated. To illustrate that, I have here another the same model already pulled, and you see here just a small sample of some nesting of these panels into master panels. Remember, these master panels will need to be produced on this bigger machine. So I'm here from inside AutoCAD. I'm representing the application that customer will use. So if I do the same here, update, look to this panel here. This one. The moment I make it selected, it will update as well. So the house itself updated, as well as all dependencies on that in that ATA model. So you see, it's a real update rather than recreate. So that's definitely.
The nesting is really important for the fabricator. So that's really a big thing.
And one other thing that we did this week is we started to focus on beams and tools. So here you see a more complex beam with dovetails and tenons and so on. That model was also pulled in from Revit. So it follows the same flow. So there's that HFDM is not only for the CLT oriented customers, but also for timber framing, Abun centers, and everything. There's something else you want to show?
Yeah, indeed. So we talked about Revit, we talked about AutoCAD, ACA as well. Also, we had some help from a colleague of our, Bill Malcolm. Probably some of you guys know him already. And he invested some time in our application, the hsbShare, which is used to collaborate between the fabricator and the modeler. So here we have an environment. This is all set up. Let me see if I still have. I'm going to just open the one project that we are going to use. CLT project here. This data has also been pushed from Revit inside our own repository. With this one, the HFDM output actually loads all the data that is inside HFDM itself. So once again, we can just start clicking. It's already linked with our viewer as well. We can just see what's going on in the model itself, and so on and so on. And if we then go to our unique ID that was modified, the wall here. Just going to click it again. You can see that action is modified. We can see when it was modified, by who was modified, and so on. So this is really valuable, crucial data that's already also available in our hsbShare environment. So I think this concludes our demo.
This concludes our demo, absolutely.
Yeah.